Hello friends, let's see the longitudinal stresses in the pipeline. I'm going to draw some basic theories about it so that it will be easy to explain. Of course the pipe is circular, so I'm going to draw a pipe which is circular and a cross section side view of it. Now since we are talking about longitudinal stress, we are going to have some kind of ends of the pipeline system, and our pressure P is going to act on each end of the pipeline. Okay, so imagine that it's a bullet or some kind of a cylinder with end caps, and the pressure is acting equally on each side. So as we all know and we have seen in the first lecture, stress is nothing but force upon area. Now we are talking about the longitudinal stress. So to calculate the force which is acting due to the pressure in the pipeline, so pressure of course is a component multiplied by the cross section area of diameter d. We are going to consider OD of the pipe. So pi by 4 d square, which is area. This will give us a force acting. Now we have to see the resisting area. So resisting area which is offered by the pipe, which will basically try to balance this pressure force acting in the pipeline. So it will be nothing but, if you imagine that the pipe gets cut into two halves here, okay, and it's having a thickness, the pipe is having a thickness T, which is nothing but the thickness of the pipe T. So the resisting area is going to look like a ring, okay, of thickness T and radius D. And what is going to happen is this, so basically this cylinder is getting divided into two parts. Okay, and it's going to look like this. So diameter D and thickness T. Okay, so the resisting area will now be pi into D into T. The calculating the area of a ring, this is the simplified formula, which is pi dt. For the simplicity we are going to take OD instead of average D. So as usual, force upon area, resisting area, will give us the stress in longitudinal direction, which is nothing but PD upon 4T. Okay, so this is the longitudinal stress of the pipeline. You will notice that in the first lecture we saw hoop stress, which was PD upon 2T, whereas longitudinal stress is PD upon 4T, which is nothing but SH by 2. So longitudinal stress in the pipeline due to pressure is half of the radial stress. Okay, and this is the principle which is applied in saving the material, because in the dished ends of the vessel or the LPG carrying tankers, they use this principle, and because of that the dished end thickness, in that the stress is acting in the longitudinal direction, whereas in the pipe itself or the tanker itself, the shell of the tanker, it is acting in the radial direction. So basically what happens is the thickness of the dished ends is always half of the, and they are basically hemispherical. If you consider hemispherical for the simplicity, then that thickness will be half of the shell thickness. So if I draw a vessel here or a LPG carrying tanker on the truck, this thickness of the dished end or end will be approximately, or will be basically T by 2 if the shell is of T. So this is the kind of a application in the day-to-day industry where the thickness is minimized. Anyway, from the pipeline perspective, the radial stress is hoop stress, longitudinal stress is SL, basically is half of the SH, and if you want to calculate, basically it's not used for the thickness calculation, but because pipeline thickness, normally what we calculate is the shell part, not the end parts, distant end parts. Therefore, SH is required for the pipeline thickness calculation, but SL plays important role in the stress analysis of the pipeline system, where longitudinal stresses are compiled and then they are analyzed together, and in some cases component of SH also plays some role in that, which we are going to see in the further lectures. Hope you understood the SH and SL, basically hoop stress and longitudinal stress, in the first two lectures. And if you are enjoying this, please give your comments and suggestions, and I will continue this further, and then it will help me to improvise and add new topics. If you have any doubts also, I can solve. Thank you.